Project 2.4 is called Secrets and Safes, and just similar to what we did in Activity 1.5, where it's the project 2.4, this should be the biggest and best thing you've done up until this point. There are going to be some different materials and tools that you might need to use for this, and I definitely have some supplies if you would like to use those for this. If you look at the top, the materials, most of these things are in the back of the room like they always have been for all of Activity 2.1, 2.2, and 2.3. Suggested miscellaneous building materials. I have cardboard, I have duct tape, there's scissors, we have aluminum foil. You may need to bring in aluminum cans if that's something that you want to add to yours. Velcro, we can definitely look into getting that, and other miscellaneous materials. This is where you're going to start to kind of use your creativity to go with the coding and to think real world situations for why you would design and why you would make something that you're going to make. Secrets and Safes rubric. If you click on that, it's going to take you through the different components. There's a planning piece, so once you figure out what the directions are and the instructions, you're going to want to plan it out. You're going to want to sit and think about details and what you want it to actually look like and what you want it to do. Then you're going to go into the actual programming of your plan. Debugging, we've spent a lot of time this quarter debugging. So once you actually get into the MakeCode website, how do you debug the situations or the code that's not working correctly? I would also add in here troubleshooting. So when you have different materials and different components, inputs and outputs connected, there will be some times where you have to troubleshoot. We have to figure out, okay, this one doesn't work with this, so how can I change it and make it work? Selecting resources, and it's going to just talk a little bit about hardware that meets the needs of the user or the environment interaction. So this will make more sense once we get into the directions. Collaboration, definitely at this point in the class you are hopefully working with a partner and things are working and really clicking for you. Sharing, this is where you're going to share your project with me, and I may even invite in some other guests from the high school, maybe some administrators or principals. So that's definitely some things you want to look at before you jump right into your project. And you have access to that the whole time, so keep referring back to that. Keep it secret, keep it safe. Definitely want to watch this video. It's going to kind of set the stage for what we're going to do for Project 2.4. It's going to talk a little bit about security device options. So here's the three main choices for what you and a partner are going to be able to create. A system that alerts you when someone has opened a notebook of secrets. Now this, if you don't want to think of it as a journal, that's perfectly fine. It just needs to have some type of a book where it has a security device hooked to it. Number two, a device that sounds an alarm when a spy removes a priceless object from a locker, box, or safe. And this is, you're going to want to maybe think about the pressure sensor. That could be one of the main sensors for this one. Number three, a system that notifies you when an intruder is detected in a restricted area. So this is where you're thinking about your inputs, your outputs. So think big picture, what type of security device do you want to build? Then you need to start to think about, how am I going to lay out the plan for this? What do I need to do, my inputs, my outputs, what do I need to have set up in order to make this run successfully? It'll take you through the design requirements. You definitely need to pay attention to these as well. Your device uses at least one input component to trigger the alarm. So that's why we spent the time on the inputs. Your device uses at least one microbit to run a program. Now that right there is saying your team may choose to connect 2 microbits. When I did this project a couple summers ago, a couple years ago, it was pretty awesome. We actually used 2 different microbits, and it sent the message to the other microbit. There's an alarm, something was triggered, something was activated. Your device uses at least one output to alert people. The user can activate and deactivate, turn on, turn off the device as needed. Now that is huge. If you have a locker alarm and it scares away the person, you have to be able to shut that off. How do you shut it off so that it's ready to be used again? So there's a lot of really high-level advanced thinking that goes into this project. Here's your design process, and I love this thinking for many reasons. You're going to define the problem. It's the security issue. I'm going to generate some concepts. I'm going to write down some possible ideas. I'm going to design a solution, I'm going to build and test it. I'm going to evaluate the solution. And if I don't like it, I'm going to go back up to previous steps. So if I build and test and it doesn't work, I go here, I go back. I can go back up. When I'm satisfied with the solution, then I'm going to present the solution. And the next couple steps here, they're going to walk you through this process step by step. They're the big headings coming up. Define the problem. Take a few minutes, discuss the options. What's really awesome with PLTW, it's going to break it down in very manageable steps. Here's your generate concepts. It's going to talk about listing some ideas. Design a solution. If there's a problem, you have to be able to present a solution. You have to design the solution. Somebody keeps breaking into my car. Well, what would I do? I'm not going to just say, oh, it's no big deal, it's fine, keep breaking into my car. I have to figure out a solution for that. So your solution is going to deal with whatever security device issue you picked. What to do? Here's your flowchart again. This is going to take you through, hey, make a flowchart. Start to put your ideas on paper. Build and test your device. This might take you 3 days. It might take you 5 days. It depends on how quickly you're moving with your partner. Please do not rush this step. If you're testing your device and it does not work, try something different. You have to try to figure out how to make that work. Test it often. While you are building your security device and coding the program, test often. Don't wait 4 days before you test it. I might build a small section. I'm going to test it right away. Doesn't work? I'm going to refix it. I'm going to fix that part. It does work? Great. I'm going to move on to the next section. Here are your debugging steps, which we've covered before. Activity 1.4, we touch base again on 2.3. Again, they highly recommend that you name it this way, with both team members' names. Evaluate your solution. Does your design solution and program work? If your answer is no, what should you do? You've got to go back up. You have to go back to some previous steps. Sharing your code, presentation practice tips, and this again is all getting you prepared for the high school level. Document your project with photos. You have a cell phone? Let's use it. I can take a picture, I can send it to you, I can email it to you. This is where you need to celebrate what you've created, what you've designed, what you've made. Present your solution. At this point, you're going to present your project, secrets and safes, to me. Hopefully at this point we have some other guests coming in to watch how outstanding your project is. Include visuals. Those are check boxes if you want to use those. There's your conclusion questions. And at this point, you should feel pretty proud of what you've created. If you don't, you may want to go back a little bit and add to it. All right, thanks a lot. Best of luck, and I cannot wait to see what you create.